So, hello everybody. I'm really sorry about the delay, but as you probably noticed, we had some problems with the video. Anyway, thank you very much for joining me for this session. As you probably know, I'm going to talk about the JSON support in a number of relational databases. My name is Antognini. By the way, I saw in tab that I'm working for Oracle. I wasn't aware of it. Actually, I'm working for Trivadis in Switzerland. I'm a consultant there, and I'm helping our customers to take advantage of database engines. So let's skip this part. I just love to handle performance, especially related to Oracle. And otherwise, I'm an Oracle ACE director and Octable member. About the agenda for the next 40 minutes or so, I will start, of course, with a short introduction about the topic. Then we'll have a look to the three main topics: generating, storing, and querying JSON data. Then we'll close with a summary, and at the end some links if you need more information about what I'm presenting here. Now, JSON, or first of all about multimodal database engines. That's a topic that is now discussed for several years. I would say the point is, in my opinion, quite clear that there is no single database model that fits all requirements. Okay, if you have a very simple application, maybe one is enough. But if you have something fairly complex, probably you need several data models at the same time in the same app. In the past, when we had this kind of situation, we ended up using also several database engines. But if you are not developing something really big, it's probably not the best thing to do, because if you have 2-3 engines in the same projects, it might be difficult. And that's the reason why a few years ago, the database engines, no matter whether they were relational or coming from the NoSQL part, were starting talking about multimodal. That means supporting several data models at the same time. And if you look at the leading edge database engines today, it doesn't matter, again, if they are RDBMS or not, basically all of them are multimodal. Of course, in the core, probably they support only 1 or 2 models, but the point that they give you an API that lets you deal with different type of models. Okay, so the point here at the end is that you might use only one database instead of several of them. And even though you are working with relational data only, remember that sometimes it's also required to provide this data in a different format. So being able to support something like JSON could be an interesting feature for a relational database. Now, JSON use cases. When you encounter JSON and you deal with databases, there are, I would say, a small number of use cases. The first one is to export some data, whatever the format is, could be relational, could be something else, to JSON. This is usually used if you want to move data between 2 database engines. Okay, again, they can be completely different. For example, for one customer, I had to move some data from a relational database to a graph database, and someone defined a JSON schema. So the point was to generate this JSON structure from the relational database. Okay, so you might have a complex predefined schema that you define yourself or somebody else. Or you can also decide to use JSON instead of CSV file. CSV have a number of, let's say, problems. If you start using special characters and stuff like that, you need escaping or whatever. And in JSON, everything is more or less defined. So instead of using CSV today, you can use really a plain JSON file, and it should work well. So this is the export part. Of course, you also have the import part. So you get some JSON data from somewhere, and you have to import it. And here I will say there are the 2 use cases. First one is that you have to convert the JSON data in relational. And the second one is that you take the JSON and you store the JSON either directly or with small conversion in between. Okay. But the export-import, from what we see, is quite frequent. If you use JSON really to store data, of course, the idea would also be to implement a JSON document store in a relational database. Not something that is probably very sensible, but in general, you can do it if you need. And finally, I will say an important or interesting property of JSON is to use it as an extension of the relational model. Because if you think about the relational model as it was originally defined, today we are far away from that definition. So sometimes we have also really complex data structure inside the relational databases. And so I will say the two typical use cases in this case is to support extensible schemas. So you have an application that let the user define, okay, but I want to put these 30, 40 additional attributes in my database. So it's quite easy to implement that with a JSON document. Or it could also be interesting to handle a high number of sparse columns. Here I had one customer that was storing thousands of different attributes about customer, for example. In that situation, instead of defining one column per attribute, you can also define, for example, a JSON document where you store only the information that you have. And in general, they're not all of them. So these are more or less the typical use cases, at least that I encountered over the last few years. Now, if you are talking JSON and relational databases, for me it's very important to also mention SQL JSON, which is basically the extension of the SQL standard to support JSON. Okay, because I expect that every relational database supports SQL. It's not necessarily the case. You might have a relational database without SQL, but in general, all of them do. Okay, and a couple of years ago, the ISO standard was extended to support JSON. In practice, if you look at the standard, you will see that SQL 2016 has in total 44 new features. Okay, it's important to say that all of them are optional, and now for a number of years, all new features in the standard are optional. That means that you have a database which is following the 2011 standard. You can say, I'm SQL 2016 also compliant, because all of them are optional, so nobody cares if you implement it or not. But anyway, from these 44 new features, you have 22 which are related to JSON. So half of the extensions to the 2016 are related to JSON, which is, I think it's quite a lot. Okay, if you check the standard, you have 3 use cases, basically, which are covered by the new feature. The first one is to generate some JSON data from a relational model. Okay. The second is to persistently store JSON data in a database. And the third is to, of course, if you store this data, you also want to query it, so to get out the data from the database. Okay, and if you see these 3 use cases, basically, you can match what I mentioned before. With these 3, you can basically do almost everything, with one exception, which is not covered by the standard, is basically to modify a JSON document. Okay, so you have no functionality that does it. Of course, you can always delete and insert, but it's really a very simple implementation. As far as I know, the guys who are working on the new standard are extending it also to implement this feature. Okay, so that you have some function that, of course, do it in a decent way. But at the moment, we have no standard functionality for that. Now, during this talk, I will cover this also feature of these databases. I decided to take the 2 main, I will say, open source, so MySQL and Postgres, and the 2 main commercial databases. Basically, they are the newest release. I would say the only one which is a bit outdated is SQL Server, because the 2019 19 or what they call it now. It's still not production as far as I know. For the other one, I must say, if you take MySQL 8.0, whatever, more or less the feature are almost the same. There are small changes over the last year or so. And the same with Postgres. They did quite a lot of changes between 10 and 11 in JSON, but 11.1, 2, and 3 are quite similar, or maybe even identical, except maybe for some bug fixes. Okay. So the idea for the rest of the presentation, I will basically check what features are available based on what was defined by the standard, because I find it is a good way of starting or following it, simply because one, I like standards, and second, I decided to not try to cover or to talk about performance benchmarks and so on, because it's, in my opinion, really difficult to do a decent benchmark that compares databases. The use case, it's really very important there to decide what is working and what not. So it's more interesting, in my opinion, to check what is provided by the databases. Then, of course, I also did some tests because I was anyway curious to know how good they can be, but I'm not covering, again, performance here. So the first topic is generating JSON data. So basically, when I mentioned the export use case before, the idea we have some relational data and we have to generate some JSON data from it. If we check the standards, they provide some constructor functions for that use case. Basically, there are 4 functions which are in the standard. There are 2 of them that let you generate some JSON object, whatever it is. So it lets you generate key value pairs based on the content of the database. I put between parentheses the reference to the standard. So if you want to check the standard where it is specified, or also the documentation of the database engine you are using, for example, in the one the SQL reference of Oracle, if you check in the appendix, you can see we support T8011, but not T8030, whatever. Okay, so sometimes they document which feature of the standard database engine supports. So you have 2 to generate objects. The difference between the 2 is that the second one, the JSON object ag, is basically an aggregation function. Think about it like when you do a min-max, whatever, but here you aggregate data together. So you take several rows and you generate only one row. And the other 2 are to generate arrays. Here's the same thing. We have 2 functions, one that can be used also to aggregate data, the other one not. Okay. And basically with these 4 functions, you are able to more or less generate whatever you want. Because at the end, JSON, it's really simple if you want, so you don't need a lot of feature. Now, that was the point where I wanted to do a demo live, but since I was not able to use my PC, I just pulled some files. I'm sorry about that, but let's try to, at least I can show you something. The first one was an example here about JSON object. As you can see, it's a bit small, but the idea is basically JSON objects. You can provide a series of key value pairs. The key, of course, is the JSON key, and the value is the value associated to it. And you can specify how many you want. Okay, really simple. And then at the end, you get in this case, I have 5 rows. Every row corresponds to one row in the relational model. With this key value pair for department number and department name. Okay. Of course, I can do exactly the same. This is for department, for the employees. By the way, I'm using the demo schema, which is part of the standard. If you're asking yourself from where this structure are coming from. So employees is something similar. I can say, okay, show me for the employees for one department. I get the stuff. And then what is, of course, necessary if you want to create complex objects is to start combining or providing the output of one function, in this case JSON objects, as input to another function. So in this case, I say, okay, let me generate several small objects for the employees, and then I will group everything together with an array. So as you can see below, now I have one row, okay, that's stored for every object in an array. And if you continue with that pattern, you can say, okay, I have here a JSON object, then I can put subcase to deal with nulls. I can put everything in one array, and then put this array as a value for another key value pair of another JSON object, and so on. And so you start making more complex objects, okay? But in this case, we still have 5 objects. So if I want to put everything together, I can put the previous query in a subquery factoring clause, and then use here another aggregation function to put everything together. So at the end, you end up with one single JSON document that has this structure here. Okay. So the point is really writing simple SQL statement and combine the different functions to get the output you need. Okay. So that was what I wanted to show you in the first demo. Now, if we check out the 4 database engines support these 4 functions, we can say that MySQL provides the functions. It's interesting because they have the same name, but implementation is different. So, for example, the key value keywords doesn't exist, so you just have to specify commas, stuff like that. But I will say if you take the query I showed you before and you have to rewrite it, for MySQL it's a matter of a couple of minutes. You just remove some stuff, and that's it. Okay. Where MySQL doesn't do a good job is to control the output. According to the standard, there are a number of parameters to deal with nulls, with failures, and stuff like that. And MySQL has no such feature. So if everything goes fine, it's fine. Otherwise, you have to start dealing with such exception. But they also provide additional function for that purpose. For example, for dealing with nulls and stuff, you can use additional functions. If you check Oracle database, it basically supports everything. There are only some advanced, what I call here advanced functionality, which are missing. But in general, it's a good implementation based on the standard. Postgres, interesting. They provide function with similar names. At least they're not the same names, but the implementation is almost the same as MySQL. Not the standard, okay? And like for MySQL, you do not have a lot of way of controlling the output, but from the other side, they implement a lot of additional functions. In Postgres, you have quite a lot of function in that area. So instead of 4, you have more like 24 or so. Finally, SQL Server. It's interesting to notice that they completely use a completely different approach, so it's not at all based on functions. Basically, they extended what they already had for XML. I don't know if you are using the XML functionality to generate XML from SQL Server, but they have a for XML clause, and they did the same thing for XML, for JSON, and they did a for JSON clause. I have here an example just to show you. It's the same query, generates exactly the same data. Basically, what you can see is that you have, for example, here one select statement, and then at the end of the select statement, you say for JSON parse. Okay, then it converts this part in JSON, and then in the same way as the standard, you combine queries, and at the end of every query, you get for JSON parse. In this case, also another option to deal with nulls, and so on. So every time you write a select select from whatever, okay, then you add JSON pass for JSON pass, and then you get exactly the same output. Maybe the order is different, but that's not important. If the order is important, you have to use order bys as always. So it's a completely different way of implementing something similar. But the important thing to notice is that these features are available, and as far as I saw, you can generate more or less the same documents, no problem. Okay, next topic, storing JSON data. So now let's say that you really want to store JSON in the database, not only relational. And at this point, it's important to add some comments about storing or designing JSON documents, because it's a bit outside of the topic, but I will say it's important to say that JSON can be good because it's flexible. More or less, you have one column. If you want, you can store the whole database inside it. It can be fun. And but always remember, when you have something which is very flexible, from the other side, it's probably not performing well, and yeah, depending on your use case, it might be really bad. So in general, I would say the best thing is to combine both approaches. So you have some stuff which are relational, and then, as I mentioned before, for some specific use cases, you say, okay, this part I use a JSON because it's more convenient to do so. But storing everything into JSON, I already saw it, for example, with XML, where the table had one ID, one date column to know when it was modified, and then one XML attribute. And then you had a couple of hundreds tables exactly with the same structures. So this stuff do exist. And remember, if flexibility is good when you store stuff, but later on it might be challenging. So interrelational, let's say, way of thinking, you have a schema on write, so you know what the schema is, and if you are going with the JSON way, it's more a schema on read, so you never know what you are going to read, so it won't be nice because your code will be a mess with a lot of if, then, and so on. Okay, so it's good to use them, to use JSON, but be careful. You need some structure. You need to know what your schema is, at least for most use cases. Then if you are implementing some kind of data lakes where you can store anything and you don't care about the query part, that might be fine enough. Okay, now talking about storing the JSON data, somebody might expect to have a JSON data type to store it, but actually the standards say, no, we do not need a new data type. Basically, we want to take advantage of additional data types that are already there. Okay, where you can store some character strings, okay, and they are fine and enough for what you need. The advantage of doing so is quite simple to be implemented by both the database engine implementers and also by the tools that use the database engines, because you do not need to extend your API. If you store everything as a text, okay, your tool can export this text. Your, I don't know, interface you use to execute queries already knows text, so it's easy to implement. From the other side, what you don't get if you store it as a text, you don't get validation, which is not good in general. We love to have validated data in the database, so you know that it's valid and that you can query it without struggling too much. And from the other side, it's not optimal when you query it, because if you have some binary format which is optimized for the query part, it might give you much better performance. Okay. So what's the standard decided? It's really an easy way to implement it. Also, in this case, they might change their mind or extend the standard to support something else in the future, but for the moment, it's what we get. Okay. If we check what the database engines do, MySQL, they do implement a JSON type. Okay, so they don't follow the standard. You really have a JSON type. Oracle follows the standard and say you can store JSON in varchar2 or CLOB. It's your choice, depending, of course, how big it is. Postgres has two types: a JSON, which is if you want text, plain text, and a JSON-B, which is binary. So optimized for some operations. Okay, so you have the choice between the two data type. And SQL Server, they also do not have a type. They say just use an varchar, it's fine. Now, what is important to say for the database that follows the standard, so the database that do not have a data type, you need some validation. And it's where the standard also specified a new predicate, the isJSON predicate, exactly for that purpose. So the idea is that you, of course, create a table with, for example, a CLOB column in Oracle, but then you add a constraint that makes sure that the content is JSON, so that you get the validation. Okay, so what you can do according to the standard is to specify or create a regular check constraint, like in this case, a column name is JSON. So every time the data is stored inside it, it's also validated. Then the standard also let you specify what kind of JSON it is. Is it a value, that means anything, or it is an array, an object, or a scalar value? Okay, that's also something optional that can be specified. And also part of the standard is the possibility to specify a uniqueness constraint. So you make sure, if you specify that one, that every key in one object, okay, has a unique name, so that you cannot insert as JSON objects. For example, if I go back here in my example below, you cannot have, for example, a department with two department name. Okay. I mean, per default you can, but if you specify with uniqueness constraint, it's not possible. So this is what the standard provides. If we check the implementation, of course, the two databases that do not that have a JSON data type do not support it. Makes no sense. But what I also wanted to point out is something kind of strange, or in my opinion suboptimal, by these two databases, MySQL and Postgres, is that since they store the data, or when they store the data in binary format, they also modify the data. So in, for example, Postgres with a JSON-B, if you store an object, like, for example, a department, like I showed you before, with two names, basically only the last value is stored in the database. All other values are simply thrown away. And this is something you have to know, because if you are inserting something wrong, so what you insert is not what you get later on. So be very careful. Postgres, you can decide about it by choosing between JSON and JSON-B. In MySQL, you can't. So it's always forced a uniqueness constraint. At this point, I usually planned a small demo about it, but of course, as I mentioned, no way to do it. So be careful with these two databases. If you check SQL Server, they do not have the constraint, or the predicate is JSON. They have a function which is called isJSON. So you do exactly the same. You do a check constraint with the isJSON function, and you check the output. It's no big deal. And for Oracle, they implement a predicate, but no type constraint. By the way, the type constraint is not supported by any one of these databases. So you can only specify that must be JSON, but not that must be a JSON array. That's something maybe you can do, but with additional functionality. Okay, that was for storing the JSON data. Now, if it's stored, usually it's because you want to query it later on. So let's check what we can do in this area. According to the standard, there is a new, what they call path language, that can be used to identify part of a document. Okay, so if you want to query a document, like again the one I showed you before, you must be able to somehow identify the salary of the employee with the name Logan, for example. You have to be able to do that. Of course, in a declarative way, since we are talking about SQL. So what they define is a language that lets you do so, that knows the structure of the JSON. Okay, they have a number of parts in the standard that implements it. Basically, this thing is was inspired, but it's not not more than an inspiration to ECMAScript. Okay, so for the people who are using JavaScript, it's something you should be able to recognize without problem. Okay, but again, it's not the standard says clearly it's not a subset nor a superset. It's just inspired, so that for the people is a bit easier to get to deal with it. Just to give you an example, always based on my the standard demo structure. For example, what you can do is to say, first of all, in such an expression, the dollar is always the beginning of the document. Then you have dots to separate the different, to identify the different keys. So in this case, I say at the beginning of the document, I expect to see something which is called company name, and then you get the output. Or what you can do is to deal with arrays. For example, in this case, I say, okay, I have the beginning of the document. I have an array which is called depths. I take the first entry in the array. I have another array which is called emps, and then there are some functions which are also defined. For example, here I can say what is the size of this array, which is 3 in this case. So you can not only specify on what parts of the document to work, but also there are some functions that let you get the data type or like here the size. There are not many functions, but there are a few of them. For the arrays, you also have something like last. So you can check what is the last entry of one specific array. In this case is James. Okay, and then something interesting, you can also specify some condition. So in the case there, what you do is, okay, I take the depth array at the beginning of the document. I can say, okay, it doesn't matter which entry, so I take the star there, and then with I can add a condition, and in this case it says, okay, inside the array I'm looking for an entry with the ID which is equal to 12. And the question is, do I have such a value inside my JSON document? If yes, I get true. In this case, it's true. So again, you cannot only identify parts of the document, but you can also apply function and apply some conditions. Okay. Now, if we check the implementation of this language in the 4 databases, we can say that MySQL only has the context item, the dollar. Okay, most of the accessor, so what we have seen before for the array at the start, the 0 and so on, or the number of the entry in the array works, but they do not have the functions and some other stuff. Oracle supports most of the functionality, but not everything. For example, predicates and some predicates and methods are missing, but they have a fairly good implementation. Postgres, from the other side, they implement a completely different syntax, at least up to 11. It is expected in 12 that shipped, the first beta was shipped a few weeks ago, or last week, or I don't remember. Recently, in any case. So in 12, they also implemented the JSON, SQL JSON pass language. So you can use the proprietary syntax or also this syntax. So soon we will have access to it also in Postgres. And SQL Server basically only supports the dollar, the context item, and some simple accessor. So there is not much support into it. Now, if we take the language, of course, we need some operators to work with that. And according to the standard, you have a number of function or operator or like JSON exist, which can be used typically in a where condition to identify whether you want to, whether one specific expression is satisfied or not. Okay. You have JSON value if you want to extract a scalar value. So department name, you want to get it, you use JSON value. JSON queries is used to extract a non-scalar value. So if you want to get a complete object or an array, okay, you need JSON query. JSON value is just really for a scalar. And then JSON table is basically used to generate, you can say, some relational data out of some JSON data. Also in this case, a simple example. So here I'm always using the same schema that I already referred to a couple of times. So some very simple example. In this case, I use JSON value twice, just to extract the company name and the size of an array, as you have seen before in the previous slide. Okay, here is something which is not implemented where I run it. In this case, I use JSON exist to implement again what I showed you before on the slide. So I'm looking for a document. Sorry, it's probably too. I'm looking for a document with a department number of 12, and then with JSON query in the select clause, I get this document, but not everything, just the department array, for example. Okay, it's a really simple example. And this one, maybe it's a bit more interesting, is to convert the JSON document we have seen before into kind of relational data. So as you can see, basically you can take the structure of the JSON. For example, here I take the department array, and then I say, okay, a department has a department number. Here is its location, the department name, its location. Then I say there is also a nested array. And inside the nested array, I can specify which are the columns or that maps to which attribute. And so at the end, as you can see, you get let's say information which looks relational, even though it's not. Okay, so it might be possible, for example, to define a view with something similar. So your application do not have to deal with JSON, just select this view and has no idea that behind the scene there is some JSON storing it. Okay, if we look at the implementation again for the 4 databases, MySQL implements JSON table, what you have just seen. But for the other function, they implement different functions. For example, instead of JSON exist, they have the JSON contains parse. It's something similar, okay, but different name. And instead of the JSON query, you can use JSON extract, for example. It's also a function that does something similar. And they also have additional function, not only these 2 or 3. Oracle implements the function of the standard plus some additional stuff, but the standard is not fully, let's say, implemented. There are some missing features, but in general, the support is pretty good. And Postgres, it has a completely different set of functions and operators as well. When you see in the example this at greater than, it's basically the operator to do a JSON exist, okay, and the next one is to do basically a JSON value, something similar. So they have a lot of operators. They probably have at least a dozen of additional operators to deal with JSON queries. And then they also have functions. For example, instead of JSON table, they have something similar, which is called JSON2 record set. So basically, I didn't really see something which cannot be implemented compared to the standard. So you can deal quite well with the JSON query also in Postgres. Maybe one additional point on Postgres, be careful since you have 2 data types, JSON and JSON-B. Usually you also have 2 functions. For example, you have the JSON to record set and the JSON-B to record set. So many functions are implemented twice, depending what kind of data type you are using. And finally, in SQL Server, there is the implemented JSON value, JSON query. Okay, they have a couple of additional functions, which is called, for example, OpenJSON, which is something you can say similar to JSON table. Okay. Good. Since we are talking about querying data, it's also important to mention what kind of indexes you can create on this data. I will say, simply put, you can create some, let's say, the B3 indexes created on based on some of the functions I just mentioned. So you can create something like that on every one of the 4 databases. So you can use one of the functions to extract the data and to index it. So you can get a regular, for example, B3 index in place. So it's really fast to get to specific data when you query it. Notice that in Postgres, it is supported only with JSON-B. Okay, so as we have seen before, JSON and JSON-B do not behave in the same way. And if you need performance when you query the data, you need JSON-B. Otherwise, it won't be nice. Okay, and again, as I already mentioned before, be very careful. If you don't know the structure of the JSON document, it won't be easy to create, or maybe not possible to create a selective index to access to this data. And if you really have no idea about the structure, what, for example, Oracle database and Postgres support are inverted indexes. So you can really index some text and then do some searches on the inverted indexes. But be careful, inverted indexes in general, they are better than nothing, but the performance won't be as good as with a regular B3 or a more selective index. So to summarize what I show you, I will say on the one end, if we are only talking about the support of SQL JSON, we can say that from the 22 features that the standard has, MySQL supports probably partially 4 of them. Oracle, according to my test, supports 4 features fully and 12 partially. Well, so even though there is the best support that we have seen, it's far to be complete. Postgres, I would say there is no support. With 12, as mentioned, there is the SQL JSON path language, which is coming. And if you check the entries in the current commit fest, there are 2 additional patches that are meant to implement also the function that we have seen. And I must say these patches exist for a long time now. I guess already with Postgres 10, probably they were part of the commit fest, but they were always they wasn't committed. So it's already a couple of years that they are working on this stuff, but they never made to the production status. But they are coming, so I will say with 12, there are good chances to get at least the path language and maybe also some of the functions. And SQL Server, again, like for MySQL, the support is really weak. So what, in my opinion, is really good is the JSON support of all functions, of all database engines, even though maybe some do not support the standard. They really have a lot of functionality to deal with JSON. And from what I tested, they are really good. You can really think about using them. So it's really a possibility to reduce the number of database engines by using a relational database, at current relational database, I will say current release of these databases. And what is also good from what I see, since I wrote the first version of this presentation, it was 1.5 years ago, they are getting better and better. And this is really good. In general, as already mentioned, the SQL JSON support is weak. Oracle has the best of it. I would say it's not surprising because Oracle and IBM wrote the standard basically together. Okay, so it's to be expected that Oracle supports the standard. Even though you can say that the standard was shipped after some of the functionality in Oracle were written, so sometimes they're not compatible to the standards simply because the standard was changed while they were developing it. It's a bit strange, but it is the way it is. Anyway, in general, as I mentioned, in my opinion, really to have a really good JSON support. If you need some additional information, I have some links for you here. Some are generic, some other are specific to the products I mentioned. Anyway, I'm really sorry again for the delay, so no time for Q&A, but I will be around. So if you have any question, just stop me, and I will for sure find a few minutes to talk with you. So thank you very much for your attention.